everyone. In today's session, we will study about Arduino Uno's configuration, architecture, and installation guide. First, there are two types of architecture. The first one is von Neumann architecture, which is based on the stored program computer concept, where instruction data and program data are stored in the same memory. The main characteristics of von Neumann architecture are it uses single processor, one memory for both instruction and data, executes program following the fetch decode execute cycle. The bottleneck of the von Neumann architecture is the instruction and data both are stored in the same memory. So the buses are used to fetch instruction and data. This means CPU cannot do both things together. That is, read an instruction and read or write data. So in this architecture, the CPU communicates with a single data and address bus to RAM and ROM simultaneously. The, sec- um, the second architecture is Harvard architecture, which is basically developed to overcome the bottleneck of the von Neumann architecture. Harvard architecture is the computer architecture that contains separate storage and separate buses for instructions and data. The main advantage of having separate buses for instructions and data is that CPU can access instructions and read or write data at the same time. So there will be separate memory for a separate memory space for instructions and data, which helps physically separate signals and storage and data memory. The processing unit can complete an instruction in one cycle. Now, here is a short comparison between von Neumann architecture and Harvard architecture. So, here are the comparison points, and the first point is description. So in von Neumann architecture is a theoretical design based on the stored program computer concept, whereas Harvard architecture is the computer architecture that contains separate storage and separate buses for the instruction and data. The second point is memory system, where von Neumann architecture has only one bus that is used for both instruction fetch and data transfer, whereas Harvard architecture has separate memory space for instructions and data, which physically separates signals and storage and data memory. The third basic comparison is von Neumann architecture has processing units would recover 2 clock cycles to complete an instructions, whereas the processing unit can complete an instruction in one cycle in Harvard architecture. The use of von Neumann architecture is usually used literally in all machines from desktop computers, notebooks, high performance computer to the workstations. Whereas in Harvard architecture is a concept used specifically in microcontroller and digital signals processing system. It is a visual representation of architecture comparison, where in von Neumann architecture a single shared memory is using an shared data and instruction bus, whereas in Harvard architecture separate instruction memory is there and distinct data and instruction buses are there. Now we will discuss about the broad descriptions of Arduino Uno's uh, configuration. So here are the pins and key components of Arduino Uno, where the first one is power via USB. The Arduino Uno board can be powered by connecting a USB cable from your computer. This also facilitates programming. The second one is power via barrel jackal. It is the alternatively the Arduino board can be powered directly from an AC means power supply by connecting it to the barrel jack. The third one is voltage regulator. This The third one is voltage regulatory. This component controls or stabilizes the DC voltage supplied to the Arduino board, ensuring reliable operations for processing and other elements. The fourth one is crystal oscillator. The crystal oscillator is crucial for timekeeping within the Arduino, allowing it to accurately calculate time. It is typically operates at a frequency of 16 MHz. The fifth one is reset functionality. The Arduino board can be reset, restarting the program from beginning either by using a on-board reset button or by connecting an external reset button to the dedicated reset pin. Next, power supply pins. These pins include 3.3 volt and 5 volt output for powering various components, multiple G and D, that is ground pins for completing circuits, and win pins which can also be used to power the board from external sources. The next one is analog input pins, which is which has 6 analog input pins A0 to A5 that can read signals from analog sensor like humidity or temperature and convert them into digital values for the microcontrollers. Next, main controller. This is the brain of the Arduino board, executing instructions and managing all operations. It's usually an ATMEL chip, and knowing its specific IC type is important for programming. The next is ICSP, that is in-circuit serial programming, an AVR programming header consisting of MOISI, MISO, SCK, reset, VCC, and GND. It's often referred to as an SPI, that is serial peripheral interface, used for communication and programming. The next one is power LED indicator. This LED indicate lights up when the Arduino board is correctly powered, providing a visual confirmation that the board is receiving power. The next one is TX and RX LEDs. These LEDs indicate serial communication activity. The TX transmit. LED flashes when data is being sent, and RX, that is receive, LED flashes when data is being received. They are also linked to digital pins 0 and 1. Now, digital input output pins. The Arduino Uno has 14 input output pins, 6 of which support PWM, that is pulse width modulation. These pins can be configured as inputs to read logic values 0 or 1, or as outputs to drive components like LEDs and relays. AREF, analog reference. This pin is usually to set an external reference voltage between 0 and 1, 0 and 5 volt, define the upper limit for the analog input pins. Now, the next configuration Arduino Uno pins is there can be digital pins or analog pins. The Arduino Uno feature 14 digital pins 0 to 13 that can be configured as either input or output. 6 of these pins, that is 3, 5, 6, 9, 10, 11, support pulse width modulation, that is PWM, allowing for analog-like control of digital devices, whereas analog pins with 6 analog inputs A0 to A5, the Arduino Uno can read vary voltage levels from analog sensors, converting them into digital values for processing. Additionally, dedicated ground and 5V pins are available to provide stable power to external components, simplifying circuits design and power distribution. Now we will discuss about the installation of Arduino Uno. So for Arduino Uno, the requirements are Arduino Uno board and USB cable. Uh, these are the core components for project essential for both programming and power. The compatible computer for such like a desk or laptop running Windows, Mac OS or Linux is required to run the Arduino Uno IDE. And the third one, the most important one, internet connections necessary for downloading the Arduino IDE software and any required libraries. Now, for the Arduino Uno installation, we have the Arduino Uno IDE is Arduino IDE is an open source software which is used to write and upload code to the Arduino board. The IDE application is suitable for different operating systems such as Windows, Mac OS X, and Linux. It supports the programming languages C and C++. Here IDE stands for Integrated Development Environment. The program or code written in the Arduino IDE is often called a sketch. We need to connect the genuine and Arduino board with the IDE to upload the sketch written in the Arduino IDE software. The sketch is saved with the extension INO. Now, the step 1 is gather your hardware. First, you must have your Arduino board. You can choose your favorite board and a USB cable. In case you use Arduino Uno, Arduino Duino Nano, Arduino Mega 2560 or Dicelema, you need a standard USB cable, A plug to B plug, the kind you would connect to a USB printer. Second, download Arduino IDE software. You can get different versions of Arduino IDE from the download page on the Arduino official website. You must select your software which is compatible with your operating system, that is either it is Windows, iOS or Linux. After your file download is complete, unzip the file. Launch Arduino IDE. After your IDE software is downloaded, you need to unzip the folder. Inside the folder, you can find the application icon with an infinity label, that is application.exe. Double click the icon to start IDE. Open your first project. Once the software start, you have two options: create a new project, or to create a new project, select file, then new. Now select your Arduino board. To avoid any error while uploading your program to the board, you must select the correct Arduino board name which matches with the board connected to your computer. So for these, you have to go to Tools, then Board, and select your board name. The last one is, now the Arduino IDE interface will appear. Here you can see in the menu bar there will be file name which shows the current project name and IDE versions. Then menu bar, which contain file, edit, sketch, tools, help menus. Toolbar button, quick access button for common functions, text editor for writing code, main area for writing your Arduino sketches, shows the uploading status, display upload progress and status, error messages, shows any compilation or upload errors, and configured board and serial ports, that is which displays the selected board and port at the bottom. So thank you for watching. That's it for the today's video, and we will make continue with different topics.